Continuing on in section 2.1, when 0 is added to any number, or when any number is multiplied by 1, the result is identical to the original number. We call these our identity properties. And the numbers 0 and 1 are called identities. So again, adding 0 or multiplying by 1 gets us back to the identical place we started, and so we call them our identity properties. Identity properties here. Identity property of addition says the sum of a number and the additive identity, 0, is the number. So -6 plus 0 equals -6. Or a plus 0 equals a. The identity property of multiplication says the product of a number and the multiplicative identity, 1, is the number. So 4 times 1 gives me 4, and a times 1 gives me a. In example 4, we're going to identify our properties. So here, we are multiplying, which means I know for sure it's going to be a property of multiplication. Now, I just need to figure out which one. Here, I start at -5, multiply by 1, and I get back to the identical place I started, which means this is our identity property. In B, I am adding. So this is going to be a property of addition. Now if I look, I have the same pieces. I have a 2 and a 2 and a -9 and a -9. What's changed is that my 2 went to the back and my -9 went to the front in my second part. So they moved. When pieces move, it is our commutative property. In C here, we are adding. So this is going to be a property of addition. And if we look, we add 0, which is our additive identity. It means that where we started is where we end. We end in the identical place, which means this is our identity property. And in D, you can see that all of our pieces here are being multiplied. So it's going to be a property of multiplication. We have all the same pieces. We have a 2, a P, and a Q. We have all the same pieces. So it's going to be commutative or associative. We check to see what's different. Here it's our grouping. Instead of being PQ grouped, we have 2P grouped. So when it's our grouping, it's our associative property. So associative property of multiplication. We can use unit analysis to find a conversion factor that converts a given measurement to different units. A conversion factor, such as 1 foot to 12 inches, is equal to 1. So it looks different, but it means the same amount. So 1 foot is the exact same as 12 inches. Looks different, but it's still the same thing divided by itself. So it still just equals 1. And we know that we can multiply by 1 from our identity property of multiplication and still get an equivalent thing. So the identity property of multiplication tells us that multiplying a measurement by a conversion factor does not change the measurement. And on page 817 in your book, there's a list of some common measurements that might be helpful. The Steel Dragon 2000 is the world's longest roller coaster. Its length is 2,711 yards. How long is a roller coaster in feet? So I'm going to start off with 2,711 yards. Now I want to go from yards to feet. So I need to compare yards to feet, and I need to come up with my conversion. Well, 1 yard is the same as 3 feet. So I'm going to set up my conversion factor. I'm going to multiply by this relationship. I need to figure out what goes on top and what goes on bottom though. There's two different ways we can write it. Since I have yards and I'm looking for feet, the feet is going to go on the top. That's what I'm looking for. And the yards are going to go in the denominator, because what that lets me do is cancel out my labels. Anything divided by itself. And remember, I can write this as over 1. Whole numbers we write over 1. So I have a yards in my numerator and a yards in my denominator. Those cancel out. So I have 3 goes with my feet. 1 goes with my yards. Now with fractions, we multiply straight across. So I take everything in my numerator, multiply together, and everything in my denominator, multiply together. I'm going to get 8,133 feet is my label over just 1, and we know anything divided by 1 is just itself. So 8,133 feet. Feel free to pause here and give this a try. Here, I can see that we're multiplying, so it's going to be a property of multiplication. Again, we're trying to find which property is illustrated here. Now, if I look on my left side, I have z to the 4th power. It's being multiplied by 1, and I end up at z to the 4th power. So since I start and end in the identical place, this is going to be an identity property. Again, I multiplied by that multiplicative identity, 1, and I got my identity property. Again, feel free to pause here and give this a try if you'd like. We're going to use a conversion factor to convert 400 centimeters to meters. Here I start off with 400 centimeters. And I need to come up with the relationship between centimeters and meters. Well, if we look at our conversions, it tells us that 100 centimeters equals 1 meter. Now, when I set up that conversion factor, remember when we multiply by a conversion factor, we're really just multiplying by 1. So we have something identical, it just looks a little bit different. I need my centimeters to go in my denominator because those I need to cancel. And I'm looking for meters, so those have to go in my numerator. Again, we can write a whole number as over 1. So in my numerator and in my denominator, I have centimeters. Anything divided by itself is 1. Those cancel out. I have 1 with my meter and 100 with my centimeters. We have fractions here. So with fractions, we multiply straight across. Numerator times numerator and denominator times denominator. We go ahead and simplify. 400 divided by 100 gives me 4, and my label is meters there. And that's all I have for section 2.1.